The centroid construction is pretty much, there's really no different than the construction for the circumcenter. Okay, here you're finding the intersection of the medians. And again, medians connect the midpoint to an opposite vertex. So we have to perform the construction for a midpoint. Well, that's the same as the construction for a perpendicular bisector. So if we identify a length for our compass that extends beyond half the length of the longest side, construct an arc, again, a semicircle or close to a semicircle from each vertex. You'll find the intersections. Okay, and so this allows you to locate, here again, the perpendicular bisector. Perpendicular bisector. If we extend this down a little bit, we can see perpendicular bisector. Now, this is not the location of the centroid, right? This is the intersection of perpendicular bisectors. You don't actually need to find this. All you're concerned with in this construction is the location of your midpoints. So if you connect your midpoint to the opposite vertex, so if I connect midpoint to opposite vertex, midpoint to opposite vertex, and here midpoint to opposite vertex, that is your centroid. And so the actual centroid for this problem is located right here where the medians intersect. It's not located here where the orange lines intersect. The orange, again, you don't even need to draw that whole thing when you're doing the construction. All you need to do is label the portion that is your midpoint. Right, and so the final thing is to just confirm that a centroid cuts the median into a ratio of 2 to 1. So if we use our compass here, and we measure this distance from this distance here along the shorter portion of the median. If I extend that up and I measure what you should find in this, is it winds up showing you that the lower portion is 1/3 of the whole, or the ratio is 2 to 1 for where that median's cut off by the centroid.